In section 9.3, we have two parts. The first one is going to be the definitions of the trig functions for any angle. And then in part B of this video section, we're going to do trig functions of the unit circle. So for trig functions of any angle, what I mean is an angle drawn in standard position where I have a set of x and y coordinates, and any point on that angle where I can determine the length between the origin and that point, I'm going to call R. Our definition of the trig functions of any angle, the sine of theta is y over r. It's the y coordinate over r. The cosine of the angle is equal to the x coordinate over r. The tangent of the angle is, well, let's think about sine over cosine. Y over r over x over r is y over x. And I have to stipulate that x is not equal to 0. Okay? The reason why I don't have to stipulate r not equal to 0 is because r can never equal 0 because it's a point that's on the terminal side. Well, it can't be 0, otherwise I wouldn't have an angle. Okay, so next three are just going to be the reciprocals. Cosecant of theta is r over y, y not equal to 0. The secant of the angle is r over x, where x is not equal to 0. And the cotangent of theta is equal to x over y, where y is not equal to 0. So this is one more set of trig definitions that are on your benchmark test. So make sure you fill these out on the trig definition sheet. I'm going to leave these on the board, and I'm going to work through some examples of problems of this type. So the four examples I'm going to do are finding the values of the trig functions for a point on the terminal side located at 3, -3, 5, -5, 15, -5, 12, -12, and -4, 0. And once I do these, we are going to come up with a way to figure out the signs of the trig functions depending upon which quadrant it is. So for 3, -3, here's the steps I want you to do. So I want you to plot the point. So 3, -3. Draw it. Okay. Then I want you to draw the triangle. So we're going to label our coordinates 3, -3. So the triangle, this is 3, this is 3. Okay, so you should recognize, hey, this is going to be a 45-degree triangle, so this would be 3 square root of 2. Or if you didn't know that, use the Pythagorean theorem to figure out what r is, and you would get the square root of 3 squared plus -3 squared. Well, the distance is actually 3. So 9 plus 9 is 18, square root of 18, which is the square root of 9 times 2, which is 3 root 2. Again, try to get used to anytime you see the same sides, you just multiply it by the square root of 2. So that's my r. So for the first example, the sign is y over r, -3 over 3 root 2. And notice here, I end up with -1 over the square root of 2, which is negative square root of 2 over 2. Cosine is x over r, which is 3 over 3 root 2. The 3's cancel, which is 1 over root 2, which simplifies to the square root of 2 over 2. Cosine is y over x, -3 over 3. Tangent is y over x, which is -3 over 3, which gives me -1. Cosecant, I'm going to take this version of it and reciprocate it, which is going to give me negative square root of 2. For secant, take this version, reciprocate it, and I get the square root of 2. And for cotangent, reciprocate -1, and I get -1. So again, plot the point, draw the segment, transfer it into a triangle. Notice the lengths of the sides of a triangle are always positive, even if you have a negative coordinate, and find the radius. So I'm going to do the next 3 examples. So my recommendation is you pause the video, you try to do them on your own, one at a time, and then watch the video to make sure you got the correct answers. So -5, 15. Okay, it doesn't have to be really accurate, but label your points, draw the triangle, and figure out the third side. So it's going to be the square root of 15 squared plus 5 squared, which is the square root of 225 plus 25, which is the square root of 250, which is 5 root 10. You guys have a calculator where you could have stuck this in the calculator and it would have resulted in that result. Okay, on your semester final, there will be some no calculator questions where I expect you to give me this part as your answer. So the first one is the sine. Sine is y over r, 15 over 5 root 10. Okay, so I'm going to end up with 3 on the top and a root 10 on the bottom. So quick simplification is 3 root 10 over 10. Next one is x over r, 5 over 5 root 10, which is 1 over root 10, which is the square root of 10 over 10. Y over x is 15. Oops, I forgot the negative here. So this one would be a negative. Y over x is -5 over 15. No, wrong. 15 over -5, which is equal to -3. Now what I want to do is reciprocate my answers to get these 3. So reciprocate this and I get the square root of 10 over 3. Reciprocate this one and I get the negative square root of 10. And reciprocate this one and I get -1/3. So again, my recommendation is you try them on your own, pause the video, and then check your answers. I'm going to erase and then do the next one. So the next one I want to do is -5, -12. Plot the point. -5, -12. Label it, -5, -12. Draw the triangle. And label your side lengths, 5, 12. This is a Pythagorean triple, so I know the r is 13. Okay, so next thing I want to do is figure out my values. Sine is y over r, -12/13. Cosine is x over r, -5/13. Tangent is y over x. -12 over -5 is 12/5. For cosecant, secant, and cotangent, I want to reciprocate. So I'm going to get -13/12, -13/5, and 5/12. So you should see that once you get this information down, coming up with the values for the 6 trig function should not take you very much time. I'm going to do one more example. I want to plot the point -4, 0. Notice I cannot draw a triangle here. Well, the coordinates are -4, 0. Well, what's the distance between 0 and -4? Well, that length is 4. So r is 4. And from there I can come up with my values. So I know the sine of my angle is y over r, so 0 over 4, which is 0. My cosine is x over r, which is negative 4 over 4, which is minus 1. My tangent is y over x, 0 over negative 4, which is 0. My cosecant is the reciprocal of 0, so that's 1 over 0, but I'm not allowed to do that, so I write undefined. My secant is the reciprocal of negative 1, which is negative 1. And my cotangent is the reciprocal of 0. Again, 1 over 0 is undefined. Okay, so let's look at these. One thing that we know about our definitions is r is always positive. Okay? So if r is always positive, we can determine what are the signs, SIGN signs, of the various trig functions in each of my quadrants. So I'm going to write sine, cosine, tangent. I'm not going to write the reciprocals because the reciprocals will have the same sign. So sine, cosine, tangent, sine, cosine, tangent, sine, cosine, tangent. In quadrant 1, x and y are both positive. So I have positive over a positive, which is a positive. Positive over a positive is a positive, and positive over a positive is a positive. So all of my trig functions are positive in quadrant 1. In quadrant 2, y is positive and x is negative. Y is positive, so I get a positive. X is negative, so this is negative. And x is negative. Positive over negative is a negative. So in quadrant 2, sine is positive. In quadrant 3, both x's are negative and y's are negative. So I get a negative over a positive, which is a negative. A negative over a positive, which is a negative. And a negative over a negative, which is a positive. In quadrant 3, tangent is positive. For quadrant 4, x's are positive, y's are negative. So negative over a positive is a negative. Positive over a positive is a positive. And negative over a positive is a negative. So cosine is positive in quadrant 4. The sentence I use to remember this is all students take calculus. And that will tell you which trig functions are positive. So quadrant 1, all of them. Quadrant 2, sine. Quadrant 3, tangent. And quadrant 4, cosine. And their reciprocal functions are the ones that are positive in those quadrants. So if I give you a point, you should be able to come up with all the trig functions. One other way they can ask you to come up with the values of all the trig functions using the trig definitions of any angle are if they give you the value of one of the trig functions and a quadrant that it lies in. For example, if I tell you that the sine of theta is equal to negative 7/12, and that you are in quadrant 3, you should be able to come up with the values of all the other trig functions. So the way you're going to do this is you're going to draw me a quadrant 3 angle. Okay, and you know that sine is y over r. Well, look here. I've got a negative and a positive. The r has to be the positive. So this side of the right triangle is 12. That length is 7. My coordinate is negative 7, and I just need the other coordinate. So I have the square root of that squared minus that squared, which is 144 minus 49, which is the square root of 95, which is 19 times 5, which I think is just going to be the square root of 195. Yes, it is. Nope. Square root of 95. Yep, it's just the square root of 95. So I know my x-coordinate is the square root of 95. So now I can come up with the values of all 6 trig functions. Sine they gave me, negative 7/12. Except that's a negative here for negative root 95 because I'm in quadrant 3. So I have negative 7/12. Negative root 95/12. And then a negative over a negative is a positive. 7 over root 95 is 7 root 95 over 95. And 7 does not go into 95. Then I reciprocate. Equals negative 12/7. Negative 12 over root 95. Which is negative 12 root 95 over 95. And 12 does not go into 95. And then the square root of 95 over 7. Check your work. I am in quadrant 3, so only one that should be positive is tangent and its reciprocal. So negative, negative, positive, negative, negative, positive. So that's the trig of any angle definitions.